Okay, today we're going to be reviewing how to name ionic compounds. And we're going to go over a brief summary of the rules to help clarify a couple things that have gotten muddled as we've added some complexity to it. So let's go ahead and get started. Before we begin, you're going to need to know if an element's a metal or a nonmetal. You need to know if it forms a cation, what charge it's going to form if it's a cation. If it's an anion, what charge it's going to form if it's an anion. And the difference between what a cation is and an anion is. And you also need to know those 6 polyatomic ions. So there were 5 anions and 1 cation that you need to memorize. So as a basic overview, we name the cation first, then the anion. So in this example, you see that we have sodium here. This is the first element in the compound. It's our cation. Then we have chloride. It's the anion. So it's chlorine. We change the suffix to "ide." So we have sodium chloride. That's the simplest kind of compound where we have simple monatomic ions, or ions that are made by just one element or one atom. Unfortunately, it's not always this simple, and that's what's gotten confused. So I want to try to break some of this down over the next couple of minutes to help clarify what you do when you're naming. So our first step when we name is we have to identify our ions. So the first thing I want you to do is I want you to ask yourself, is the cation a transition metal? And how do we know if it's a transition metal, and why does that matter? Well, we know it's a transition metal because it's one of the D block elements, so it's in here, or it's tin or lead. We consider these transition metals as well. And we consider them part of the transition metal family is because most transition metals can form more than one ion, and tin and lead form more than one ion. So the majority of these elements that are highlighted can form more than one ion, +1, +2, +3. Now there is an exception to this rule, and that's silver and zinc only form one ion each. Silver, Ag right here, can only form a +1 ion. Zinc can only form a +2 ion. So depending on the charge of these transition metals, that's going to change the name that we have. Second thing you need to ask yourself is there a polyatomic ion in the compound? Well, there's one polyatomic cation you have to look out for, and there are other polyatomic anions you need to look out for. And the 5 anions that you need to know are this OH negative hydroxide right here, nitrate, NO3 minus, and when I say just negative or minus, we're talking -1 charge. Sulfate ion, so SO4, it's -2 charge. And carbonate, CO3 -2 is also -2 charge. Now there's a 5th polyatomic anion you need to know, and that's phosphate. So that's PO4, and it's -3 charge. And then again, I'm going to mention that one polyatomic anion or polyatomic cation you needed to know, NH4, which is a +1 charge. So the first step that we did was we looked and identified what our ions were. Next, we need to name them. So you're going to name the cation by its elemental name. So just like in that first example where you saw sodium, that's the name of an element. We didn't change it. We didn't add a prefix or a suffix. It's just its elemental name. Now, if the cation is going to be a transition metal, and it's a transition metal that can form more than one charge, then we have to use a Roman numeral in parentheses to indicate what the charge is in a compound. Otherwise, we don't know how many of the other ions to put in. So how do we determine what the charge of a transition metal is? Well, we have to look at the compound that it's in. So in this case, in this example, we have FeO. And so Fe we know is iron, O we know is oxygen. But we don't know what the charges are, and we don't have any subscripts, so we can't do a simple reverse crisscross to figure out our charges. So what do? Well, we look at what we do know. So we know that oxygen always has a charge of -2. It only forms a -2 ion. And there's only one of them because we don't have any subscripts. So that is going to show us that we only have one oxygen. There are no subscripts. There's an implied one there. So overall, our negative side is a -2. So we need a +2 to balance that out because all ionic compounds are neutral. So we have to have a +2 to balance out the -2. Well, we only have one iron that can have that +2 charge. So in this case, we know that iron is a +2. So it becomes iron 2. And so we indicate it by writing out that word iron. We put a Roman numeral for 2 in parentheses. And then we're going to finish it off by putting whatever anion name we give that oxygen. So step 3 is filling in that blank. We need to name the anion. For our elemental ions, we're going to need to change the name. So when we have just a monatomic ion, we need to change that name. We're going to drop the ending of the ion, and we're going to change the suffix to "ide." For a polyanion, you're going to keep the name. So phosphate, nitrate, hydroxide, sulfate, and carbonate get to keep their names. In this case, with FeO, that O is monatomic. It's an elemental ion. So it becomes oxide. Last, we put it all together. So we put the cation and the anion names together. So we had iron 2 for this iron guy here, oxide for oxygen. So this compound's name is iron 2 oxide. So to summarize, the first thing you have to do is identify the ions. You need to name the cation following the rules, and then you're going to name the anion following the rules. You're going to put it all together, and you've reached your goal. You've named your ionic compound.